Thanks for joining us. It's great to see everyone on board. There's a few more joining us as we speak. My name's Trevor Pillar. There's people joining us as we speak right now, so but it's good to see you here today, Amanda, Hong. People joining us there. Ian, Jessica, Lisa, Manoj, Ollie, Noel. Just want to quickly before we start, I'll introduce Tony in a moment, the speaker, the presenter. We're going to be talking about modelling for decision makers, and we are looking forward to that. Should you have a question, there's a raise hand icon on your screen. You'll probably see that. So by all means, press that. I'll see it, and we'll get cracking. The way we arranged this today is the agenda is 15 minutes of the presenter, Tony, 15 minutes Q&A open to everybody. We'll record this. The feedback, there's a form comes up after you close off today, and it'll be just 1 minute of your time, and we use that really well to shape the future webinars each month. So this is the 6th IceForm webinar, monthly webinar, and we're so glad we can be doing this. Today's presenter, Tony, is one of Australia's leading practitioners, as you can see on the screen, in catchment modelling and water quality field. 13 years at BMT, WBM, has 27 years experience in the water industry. I'm probably speaking too fast. I want to give you maximum time, Tony. Sorry, I won't read all that. But you can see the last sentence. He was nominated as one of the top 10 water leaders by the WME magazine in 2013. I'm going to say no more right now, but let's hear from Tony for 15 minutes, and we are so looking forward to it. Thanks very much, Tony, for your time with us today.
No worries, thanks, Trevor.
Yep.
And it was lucky that I wore a slightly different shirt to the one in that picture.
Well said.
So today, what I want to be talking about is a fairly high-level overview of modelling to give you an understanding of what are some of the key issues and how they might influence what you might do. So really what I want to cover today is the modelling question, what process you might go through with modelling, and how those results that you might use out of a model might be used in decision support, some of the questions you might want to ask of yourself. And finally, what happens after you've used the model? What are you going to do with the models themselves? How are they going to be used in the future? The big focus that I really want to spend most of the time on is the modelling question. As a modeler, one of the critical elements that I see is that the question itself isn't well established up front. And when that question isn't well established, it makes it quite difficult to be able, as a modeler, to define the boundaries of what it is that we're interested in. So when we're talking about the modelling question, we've really got to be very clear about what it is we're trying to do. What do we want to know? So the examples that I've given there is, having a fairly clear statement where we understand some of the boundaries, such that if we were interested in supplying a town with water, then we need to quantify what water do we need to supply, when are we looking at the problem, and once you start to explore that question, it really then refines the problem that you're trying to understand. And so many times I've heard the second one, well, just tell me the answer. Have we got enough? Is the wetland going to work? Is the rain garden going to be big enough? For what? How? When? And so ask yourself these questions when you come up with a proposition to use a model. Ask yourself, what is it that you're really trying to ask? Do you know where that question is that you want to answer it? When it might be, because timeframes can be very important in terms of, are they decadal scale questions, or are they a question about what's going to happen tomorrow, or how do I know what the variability of a rainwater tank overflow is going to be at the end of the afternoon of a particular day. The other thing is, understand what you already know and try and quantify that and ask yourself the question, do you really need a model to answer this question? It's really important to understand where the model value might lie. When you get into modelling, I mean, you may not have to invest much. It might be a very simple spreadsheet or a simple music model or a very, very complex model, 3D model of a storage, or drinking water storage, or a bay. The level of investment that you need to make can be substantial. And so it's important to understand, what are you going to get out of that investment? The thing is, we've got a lot of tools out there, and every modeler will say they have the best model, or their model does something that nobody else's does, and you'll hear that quite often. Now, I work in consulting. I've been in consulting now for 15 years, and one of the things that I do get cross about in our industry is that there are many people who will oversell the capacity of their models to do a particular thing. What we need to have is people able to understand and critically evaluate the questions that, or the answers that modelers might give. Now, when you're talking with some modelers, they'll say, yeah, I could probably do that, but I need some more data. And so, okay, well, what data do you need? How is that going to influence the question? So when you start talking around what sort of models are out there, the choice really comes down to defining those questions well, as we talked about, but understanding some of the issues around scale, and I'll talk a little bit around some of the impacts of spatial scale in a minute, but also being very clear about what you expect of the model. Is it a particular time frame that you're interested in? Is it a particular spatial area that you're interested in? Is it a particular land use, or those sorts of, I suppose, constraints? The other thing is that, like somebody using a shifting spanner as a hammer, any tool can be used in a variety of ways. And I have seen some very creative ways of models being used. Are they wrong? Sometimes maybe, but sometimes the way you use the tool can, depending on the skill of the modeler, be quite different to what was initially envisaged. The way we ask the question should also start to reflect on, what is it that we're trying to understand about our system. I was going to put in a slide around systems understanding. It's a bit of a hobby horse of mine at the moment, that what we really need in natural resource management is ways of better understanding how our systems work. A lot of times we might focus on water quality, or water demand, or flooding, but when we start to influence the problem that we're trying to manage, a lot of times we don't understand the systemic effects of making a change. And so what the models can actually do is start to build up your systems understanding. And if you use the model not as the only answer, but as one part of that, it can be quite useful. So the way we've used them is in problem definition, prioritization, how should I deal with a particular problem, how do I fix it, and what happens if things change. Now, these problems that I've got on the screen at the moment are the typical ones that I, as a catchment modeler, have dealt with quite frequently. But there are many, many others. We've used models as communication tools. We've used them to look at valuing ecosystem services. So really the actual use of the model isn't constrained to just answering one particular question, but providing information to answer a whole range of them. So here is an example of understanding where a particular problem might lie. This is some work that I did a few years ago in the Botany Bay catchments. And really what this was about was trying to understand where were some of the loads coming from. So we were able, on a spatial scale, to understand what areas of the catchment were likely to be focuses for intervention, or that we needed to understand that's where most of the pollution might be coming from. The other corresponding element to the spatial scale is the temporal scale. Are there particular times of a decadal season? Are there particular years? Are there particular months, or even particular days or events that might actually be causing the issue that you might want to see? When you start to talk around what scale, it's also important to understand the influence of information that you might have. Here is an example of a data set that was originally available to assess a particular catchment. And what you can see with this is how coarse the data is. Now, if my issue was trying to understand the export of pollution from that particular catchment, this data set might be okay. But if I was interested in understanding the relative contributions within that spatial zone, I might need to go to something in a much finer resolution. And so what you've got here is the impact of the scale of the question you're asking, but also the resolution of the information that you might have to answer the question. So when you're asking a question to be answered through a model, it's important to start to become cognizant of what is the level of information there to support answering that question. And the other one that comes up for me, and this was really highlighted to me a couple of weeks ago, is do you really need a model? Here is an example. I was in India 2 weeks ago giving a presentation. Somebody was asking about river basin management, and that's why we were there. And they're saying, oh, well, you know, we need to understand the problems. Well, one morning we walked down to the local river and we saw these two lovely sites, which were raw sewage going into the river. So if 80% of the river flow is raw sewage, then you probably don't need a model to tell you that sewage is going to be a problem. And neither do you need to go to something along these lines where you might invest in a lot of monitoring, but really you need to take that step back and say, what is the problem? Is the problem obvious? Do I need more modelling or data to inform that? We really also now need to understand which model might do the job. And this is where it becomes quite challenging. And this webinar is not here to answer all of these questions, but really to raise your awareness around what are some of the questions that I might need to ask of a modeler or a project that might include modeling. The models that are out there, there are so many of them. In terms of that, we need to understand, is the model available? Some of these models are very expensive. Some licenses run up to the hundreds of thousands of dollars for a particular model, but some are free. What can the model do? But most importantly, and this is one of the critical elements of modelling, is understanding what the model can't do. Who's going to use it? Who's going to develop it? Who's going to maintain it? And those could all be different people. What's its applicability to the question being asked? Is it specific enough? Is it at the right scale? And then the complexity. And, you know, there's a lot of people get fixated on, you know, the model can do all of this stuff. It can be so wonderful. It can, you know, represent all of these different things. But really, it should only ever be complex enough to answer the question that you're after, but still be simple enough to understand the results. The modelling process itself, I'm not going to spend much time on it here, but there are a number of different phases. The data collection and processing phase is actually typically where you need to spend a hell of a lot of effort, and it can be sometimes up to 50% of the effort that's needed. The other area that gets a lot of focus is in the calibration part. And so data collection and calibration can take a significant amount of time. If you don't allow enough of that time for that, then sometimes the models themselves are not going to be suitable for the end use, I suppose. And then using these results out of this modelling process in decision support, it's really important to understand who is going to use the information, and being able to provide them the information out of a model. And it could be, you know, a model would produce thousands and thousands and thousands of lines of time series or pollutant export numbers or spatial maps or so on. You need to stop and say, okay, well, that's what the model's provided me, but what is it that we need to answer the question? So how do I process those results in a way and give them context to make a informed decision? Do the people who want the decision understand and know what they want? And I would say that in 60 to 80% of the time, the answer is no. And so part of the skill of a good modeler is being able to frame that information and in a way that helps support a decision that informs as many people as possible around the decision they want to make. One of the other things that I've probably learnt over the last 5 to 10 years is really starting to engage with those who may be impacted by the decision, and they're not necessarily included in a lot of projects. So if we're making decisions, say, around change in farming practice to see what's going to work, have we actually talked to the farmers and started to understand what would this mean for them? And have we framed our modelling question in the right way that we've minimised that impact or we've understood that impact? And then finally, how do you know that you've got the right answer? And that comes around building confidence in the models and the modelers, but also understanding the influence of uncertainty and knowing that the answer that I might get here and the answer that I might get there are actually no different because the uncertainty is much greater than both of them. So really understanding that and being able to say, okay, this answer is statistically different from that one because the model uncertainty says that I can understand that and resolve those two questions in a reasonable amount of detail to give me that difference is really important. And then finally, what happens once you've finished with the model? Who's going to own that model? Who's going to have the IP for it? Who's going to maintain it and update it? Who are going to be the model users? Are they the ones who developed it, or are there others? And who's going to need the model results on an ongoing basis? And do we understand their needs into the future so that the model can be developed accordingly? So finally, these models are really tools that can be used in a variety of ways. They're not always for the way that they were intended. Hopefully, the one thing you'll take away from this is to be very clear around the modelling question that you want to ask. This does require building capacity, and hence why hopefully a lot of you are here today. You want to understand what else might I need. And if you do that and you understand the limitations of the tools, the questions you're asking, the answers and the results you get, and the models themselves, you're going to end up with a much better outcome overall. Thank you.
Thanks very much, Tony. That's a fantastic overview. It's just so many people asking and talking about the growth in modelling. But look, I won't rattle on here. What I'll do is right now is just ask if you've got questions to come on screen, or maybe write them. That'll be really good. Well, we've got one question already. It's from Amanda Binks. The question is, understanding what the question actually is can be quite tricky. Do you have any tips?
Yeah, it's a good question, Amanda. I suppose the best way to start this is to start to frame the boundaries of the question. So, if I'm looking at an urban development, what am I actually interested in? Am I interested in the impact of an urban development on a downstream waterway? Is that the local stream? Is it a river? Is it the ocean? Do I understand where that measurement point of the question is, and therefore can I define the spatial and temporal constraints. So fundamentally the framing of the question really comes down to setting boundaries, I suppose. They're good questions. So how do you know where to stop with the boundary? Really that comes down to, I suppose, the regulatory questions that you might want to answer. Is it around, you know, compliance with a water quality objective? Is it around determining a particular water demand? Is it around understanding a water level in a groundwater bore? So once you start to say, okay, if I have some further information, what is it that I'm going to do with that information? So am I going to get to a point where I have the information that I want to answer the question I've got at the moment, which might be, for example, I've modelled a whole groundwater system, but really what I'm interested in is the groundwater flows into the river at the downstream point. But if all of a sudden that model gives you the answers across the whole of that groundwater system, you might say, well, the boundary was originally the end point of the downstream flow point of the groundwater, but now I actually want to focus or reframe the question back up into the system itself. And that was what I was saying about systems understanding. What the model process does, or the whole process of modelling can give you, is an understanding of that system. And really you don't know that until you go through the process. So I've found that, and one of the things that I get quite excited about when I'm doing modelling projects is the learnings that I get from understanding what information's out there, looking at the systems themselves, defining what's going on, talking to people on the land. And that last one is so important. Don't ever think you can create a model without talking to the people that it's going to influence or who are interacting with it, because you may be surprised how much more they know about that system than you do. The modelling question for you, in terms of understanding what that context is really, you may have a question that you want to answer, but that, as I said about that modelling process, that going through that process might actually give you the opportunity to open it up to a range of others. And you might say, well, we've now got this tool, it can answer this particular question. Is that going to be useful? Can you use it for some other reason?
Yep, that sounds great. There's another comment, Tony, on the chat line from Lisa Duncan, as to whether we could run more of these sessions on commonly used models like HEC-RAS and SOURCE, understand the capabilities and limitations. I was going to say that Tony and his colleagues, Jeff Podger and Tony Sheedy and John Doty, have been running a course for the Department of Environment, Water and Planning in Victoria, 2 days face-to-face and 1 day webinar, a half-day webinar, that focused on staff who were reviewing proposals, who wanted to understand the modelling process. They weren't modellers. So that's another thing I'd like to take up with Juna, and possibly we want to have a conversation with Juna about staff going in a similar direction of as this Department of Victoria have just done. But as for single sessions like this, I think it'd be a really good idea. What do you think, Tony?
Yeah, definitely. Especially just giving a bit of an overview of the software, what it can and can't do, and how it's being used, I think would be quite useful for people.
Mm.
Just a question from Hong about data-driven modelling.
Oh, sorry, what's that here? Mm-hmm.
Yeah, Hong, one of the problems that I see with data-driven modelling is that really all it becomes then is a way of, I suppose, contextualizing the data rather than being a predictive model. Now, that's not a bad thing. It's just perhaps there's an issue what we call heuristic modeling, where you get to a point that the data itself describes the future performance rather than any modelling itself. So you've just got to be a little bit careful that the data can give you some indications, but it won't give you the full range of variability, because in most cases you don't usually have enough data to understand all of the heuristics that might occur. And the heuristics are the variabilities that you might see, the different relationships between particular parameters and so on.
That's good. I reckon we can call it a day there. What does everybody think? I appreciate, once again, Tony, your time on this and effort in this. It's only a short spurt, and we are thinking of making these 45 minutes in future. In fact, it probably would make it a little easier. But once again, thanks everybody for joining today, and thanks, Tony. There is a recording of this webinar, and it will be up in the next few days. Also, I will send out the PowerPoint of your presentation, Tony, if that's okay at your end.
Yeah, that's fine. Yeah,
that's great. Yep, that's a very good overview of what modelling can do for us. Thanks very much for that, and I'll look forward to seeing you again. Bye for now. Bye.
Thank you, everyone.